We basically want to talk to you about the SysEleven Stack, which we're announcing this year, and we want to talk to you about our new approach: automate, build, and run. So first, just to give you a bit of an insight into our company, I'm a system engineer at SysEleven. I've been working for SysEleven for 4 years now, and we're basically a Berlin-based hosting company. And up to now, we've been offering like traditional hosting services. So if a client requested a cluster or servers, he would send us an email, he would call us, go through our ticketing system, and then we'd begin and set up the service for him. And sometimes that could be like a tedious pastime. It would take like between a week or 2 weeks to get everything running. The customer would then begin installing his application, maybe do some unit tests, and before everything was set up, it would take a long time. And more or less, every setup was like individually built. So I mean, we'd be using automation software like Puppet. We'd be doing like maybe perhaps 80 or 90% of the work with automation, but there would always be some config files that people have touched. There'd always be stuff which people had individually configured, which of course is very difficult to reproduce. The customer might come back and say he needed a relaunch at a later period of time, or he requested more servers, and then maybe even in the worst case, the guy that set up the initial cluster had left the company, and then you'd find he'd changed something, he'd modified a small tweak in a config file, and you'd be doing diffs between files, and you'd be looking at stuff and checking installed packages between the new node and the old node, trying to figure out why it doesn't work. Basically, a bad idea. And I would like to show you today about our new idea, how we think we ought to be running scalable setups on our cloud platform, SysEleven. I mean, there's quite a few companies like Amazon and Google which have already showed us kind of how it's to be done, and we kind of took that approach. We invested a lot of time and effort. We looked at the market. We looked at various solutions. We had loads of sales guys coming in and tell us why we should use their solution, what's so great about it, and we've been running open source software for ages. So our main focus has always been on open source. The majority of the machines that we run are Linux machines, and we're happy with that. So at the end of the day, it basically boiled down to OpenStack. So we hired a team of professionals and put them in a room and said, can you try and get an OpenStack installation up and running for us? So they did that. We installed everything and got it up and running. And then you suddenly find out, you put all these maybe 10, 15 boxes together, and you find out you can't even saturate a 10 gigabit network link. You're getting like about maybe 2 gigabits of traffic from like a standard installation. I mean, that's not good enough for us. That's not good enough for our clients either. You've got like high latencies to work with due to the software-defined networking layer. And that kind of makes it very difficult to work with. So we looked at all the different components, and we changed a few. We optimized them highly. We spoke to a few vendors which offer like underlying storage systems and software-defined networking. And we altered these components and changed them. And we also modified the hardware we work with. And at the end, after about 2 years, we received a result which we're really happy with, and we're going to go live with this with the new SysEleven Stack this year on the 1st of July. So we're really happy about that. And I would like to talk to you a bit about our automate, build, run approach. And yeah, let's get going. So I would like to give you a brief overview first about the 3 steps that we take to get clusters and systems up and running. Just give you this brief overview first, and then we'll go into every point into depth later on. So basically, you start off with automate. Automate is basically infrastructure as a code. So basically, you're setting up your infrastructure, and basically, you're putting it all into code. So you're describing your setup in a templating language. Sorry. The next step would be the build process. And the build process helps us basically build things through the OpenStack API. So what we can do is the SysEleven Stack, same as OpenStack, of course, has an API which we expose, which our customers can use. And we can send requests to the API. We can send our code, our infrastructure code, to the API, which basically makes stuff happen, which we're going to look at in a minute. And the third step is run. We want to run the full service and every component belonging to that. And at the end of the day, of course, what the goal has got to be, having our microservices, web services up and running. So gaining revenue at the end of the day is our goal. So that would be our 3 steps to a running service. And I want to take some time now to go into detail and break these 3 steps down so you can gain an understanding of how this actually works and give you a better insight into what we actually do and how we set up our system. So automate infrastructure as what? The first point we're going to talk about is templating languages. Have any people here in the audience work with any templating languages with resources? Yeah, so there's a few people around. Has anyone ever tried to set up a cluster in AWS or Google before? And maybe fired some, build up some servers from their developing machine or anything? No? Okay. So basically to do that, we need to describe our infrastructure as a code. So that can be any single component, or that can be a complete setup. So we've basically got our servers. They consist of various things. You've got a hard disk that you need to describe. You've got the amount of RAM that you require. You've got compute resources like CPU usage you may want to limit. You're going to need different resources for a load balancer than you're going to need for an application server or maybe for your database node which you're running. And we have quite a lot of other resources as well which we require. We've got the underlying software-defined networking, so our virtual network. We have routers, which basically allow our machines without a public IP to communicate with the internet, maybe to run updates or to contact your external ERP system or something else. Then you may have an internal network as well, which you need to build because you would like your application server to be able to talk to your database or your Elasticsearch instance, which you may be running on the internal network because you don't want to expose your Elasticsearch instance to the public. So all these things can be described in code. All these things can be written down and can be run again. So I mean, you can set it all up once, and you know once you've got that, this is reproducible and can be set up again. You'll also have things like maybe security groups. You want to do some firewalling. You don't want all the ports to be exposed. You maybe want to switch certain things on or off. And you may also require things like floating IPs to build your cluster. If you have a high availability service, you may want to do an IP failover if one of the servers is taken down for maintenance, or in the worst case, maybe a whole hardware node fails and you don't want to be offline because of that. You want your IP to switch to the other system and to be able to stay online and run it on your second server. So all these things can be written into the code, and we can also give the numbers of servers that we need. So you can run it for your staging setup, you can run it for your live, or even to use the Magnolia term for your user acceptance test, because you may want that slightly smaller than you would want your production environment. Just to give you a brief overview of what that looks like in OpenStack terms, this is what it would basically look like. So in OpenStack, everything that is offered is an API. So right at the bottom, in the red circle, you can see the identity service, and the identity service would be the API. You would give your credentials, you would send it to the API, and it would offer you certain services, depending on who you are. So you may have a senior developer, he may be allowed to change and alter the live setup. You may have a junior developer or someone, a back-end developer. He may be able to run testing clusters or do unit tests. So there's ACLs behind the API, so access control groups and access control lists, which can identify the person through his credentials and can tell what he is actually allowed to run. And you can see that identity authorization services connected to various other APIs. So we have APIs where you can request an image. You may say, I would like to run the newest Red Hat server operating system, or I need a Ubuntu server. So you can request that through the imaging service. Some of our clients even request to have their own images. That may be a specific form of an enterprise Linux or a form of Windows even that you may want to run in our cloud. And you can do that. And to get the system up and running, we're going to need various other components. So for persistent data, you might need a block storage. Say you want to put your document root of your web or your Java or your jars for your Java application on a persistent volume. You're able to do that too. You can put it on a block storage. And a block storage can be mounted by a virtual machine. On top of that, we have the compute resources, which allow you to allocate RAM and hard disk, as I said earlier. So you'll be able to buy a bulk. You can say, okay, I would like to purchase maybe 200 CPUs and maybe 400 gigabytes of RAM, and you can distribute those in any way you want between your virtual machines. So basically, you can run those in any form that you need them. And another important component is the S3 storage component, which is an object storage, which allows you to store files. You've got an HTTP API, and you can basically do an HTTP put. You can give them a file, and you get a uniform resource locator back, so a URL, and you're able to access that file from your application. So that would basically be an object store. That's like for disk stored in disk files stored in object stores. So basically, that's all the services. And looking at it, it's fairly complex. And you can also see right at the top is the dashboard of OpenStack. And the dashboard is basically the equivalent to what I was talking to you about with our infrastructure as a code. You can also run it through a dashboard, but that's not normally what you want to do. It's good for like rebooting machines or maybe checking your status or looking how many CPUs you've actually allocated. But everything else you basically want to do from the command line. OpenStack offers all of the tools that you basically get through the web interface offered as command line tools. So those are basically the things that you really want to use. And the last step would be step 3 is running our infrastructure. And to do that, of course, we need a few things. We need a software component. It could be an Nginx load balancer, an Apache web service, or in the case of Magnolia, maybe even a Tomcat server that we require. And we also require some form of deployment mechanism to get all that up and running, and an orchestration tool. So for the orchestration, we decided to use Ansible in our case, because that covers quite a few of the issues that we had. It covers quite a bit of the orchestration layer, so you can actually set up your virtual machines through the API with Ansible once you've done all that. And you can also install and configure all your services. So the problem that we initially said, where it might happen that someone has actually tampered with a config file, someone's actually altered something, that can't happen anymore, because everything that we require is either in an infrastructure template or in our Ansible playbook, and it can be replayed at any time that you need it. So once you've got your testing set up and running, you can reproduce that for your user acceptance tests, for your staging environment, or for your production environment. So what is the final result? The final result is reliability due to standardized, described setups. It's reliable because I can run it over and over again, and I always expect the same result. We've got a fast time to market because every component in the setup is automated. There's like no manual configuration at all. The machines get fired up through the API. All the machines are up. They're like naked machines. They don't know what they're doing. Then the Ansible comes, does all the configuration, and all of a sudden we have load balancing services. We have maybe DNS or database services up and running, ready to go, and we can use them. Once we don't require them anymore, or maybe we want to relaunch our setup, change something, we can basically shoot the node in the head and build another one straight away. And I mean instantly. And it's also reproducible. So our best practice setup is hopefully integrated into our recipe, and we never lose it. So the tweak that some sysadmin found 2 years ago is in our recipe. It's not hidden somewhere in a config file. It can't be lost. It's there to use, which is basically great. So how does this work with? Oh, sorry. So how does this work with Magnolia now? We're quite excited. I mean, a few of you were probably at the keynote yesterday where Pascal announced the partnership between SysEleven and Magnolia, and we're really excited to talk about that today because we're able to run the Magnolia Now setup as the DX-based cloud platform on the SysEleven Stack, and we can completely automate the process of building that system. But of course, that took quite a while. It was quite a bit of work. It was quite a bit of communication necessary between SysEleven and Magnolia till we got their idea that they had, till we actually fully understood what they want to do and how they want to set it up and run it. And we basically helped Magnolia create the Ansible Modules for the SysEleven Stack to get that up and running. So we created various modules for Tomcat, for the load balancer, and on top of that, Magnolia built their great software stack and their interface, which a lot of you saw yesterday, where you can basically upgrade the software, you can do your backups, you can check out your Git repository, you can do like loads of stuff with it. You've got like your different environments from your start at the bottom with your integration environment, your UAT, so user acceptance tests, and then at the top your production, and you can run all that through the Magnolia Now instance in the cloud. So what do we actually need to get that up and running? First was we need to build the service for Magnolia. To build the service takes roughly, for a standard cluster setup, about 3 to 3.5 minutes. After that, we've got the servers all up and running. Then to do that, we need at least one load balancer. Of course, in an ideal world, you're going to want a cold standby load balancer as well. You're going to want something with a floating IP on it. So if the load balancer fails, if there's any issues at all, you can basically fail over to the hot or cold standby server, and your setup is running. So that will be the load balancer component. Then we require at least 2 public servers. For a high availability setup, we need at least 2 public servers, and we can do the load balancing on the Nginx software load balancer, or it could even be a hardware load balancer if you require any additional features, and we can basically distribute the load between your 2 servers, which is great. On top of that, we need an author server for our guys that are adding the content to Magnolia. They, of course, require an author server so they can add content. That can also be done with a cold standby if you need it. In a standard setup, that would just be the one author server, which in general is enough. Because as we saw earlier, we've got all our stuff in in the cloud, we can basically reproduce that so we can build it again if we need it. So that's not a great issue. And on top of that, we needed, as I explained just a minute ago, we needed all the Ansible modules which we helped develop. So that can basically break down to any kind of application that you want. If you need help building your application in the cloud, we can help you do it. And the last component which we actually need is the Magnolia software itself. So that would be the stack, the CMS stuff which Magnolia do, which we're glad they do because they do a really good job with it. And that is then the thing which, the last component that we require to actually bring in the full setup. And to actually make the experience really good for you guys, we've decided to add a bit of DNS Magic as well. So we've basically got a service where you can, some of you may have saw yesterday, you saw the URL. You've got like you can distinguish via the URL. You've got the in production environment with a tag with a live, I believe, and then you've got the UAT environment which you can distinguish. And you don't need to use your own domain. We actually provide you with a domain to actually use it until you're actually up and running, because of course you don't want to use your production domain on your test setup at the moment. And till we get that up and running, it took us just under 9.5 minutes to get that up and running until you could actually log into the backend. And I think we can improve that as well in the second iteration. But that's what we're looking into at the moment. But I mean, 9.5 minutes to get the Magnolia setup up and running is good time. And we're happy with that. So what does that actually look like? This is basically a diagram where you can actually see roughly what it could look like. That would be a typical Magnolia setup run on our SysEleven stack. So I think I'm a bit ahead of my time, but so I hope there's going to be a few questions. So first of all, thank you very much for your time, and thank you very much for listening.